Hello all, welcome to the next subtopic of electrostatics topic, and we are going to learn in this topic electric field intensity due to a point charge in a material medium. In the previous session we considered a charge present in vacuum or the charge present in air such that k value is equal to 1, but in this case the value of k it will be present. Okay, so let us consider two charges which is present in the medium. Let the charge plus q and plus q0 be present in a medium of dielectric constant k. This is present in the medium of dielectric constant k. So since both are positive charge, so both are going to show a repulsive force between them. So this is what a repulsive force. Okay. So as per Coulomb's law, what F bar it is equal to, see I am writing now in the vector format. So F bar it is equal to 1 upon 4 pi epsilon 0 k, where k is what, dielectric constant of a material medium. This is this is nothing but multiplied by q into q0 divided by r square, where r is the distance between them. Now this side is not a vector form, this side is a scalar form. I have to multiply this by r cap such that this is now the vector form. Okay, but we know the definition of electric field. What is the definition of electric field? The electric field it is given by, suppose I am writing now in vector format, E bar it is equal to F bar divided by Q0. E bar it is equal to F bar divided by Q0. So this is equal to Q0 will be divided by F bar. What we are going to get is 1 upon 4 pi epsilon 0 K Q divided by R square into R cap. So this is nothing but the electric field which is present when the two charges are present in the material medium. So the value of k it will be equal to 1. So we can say for vacuum or air, what is the value of k? The k value is equal to 1. So we can say what is the value of E bar? E bar it is equal to F bar divided by Q0 okay, this is equal to 1 upon 4 pi epsilon 0 k value is equal to what, 1. This is q divided by r square into r cap. So this is what the electric field intensity due to a point charge present in the material medium. Okay, so this is all about the electric field derivation. Okay, or we can say electric field formula. So please pause the video and complete the things down. What we understood is, we understood E bar it is equal to 1 upon 4 pi epsilon 0 k q divided by r square. This is what E bar it is. And what is F bar? F bar actually it is equal to 1 upon 4 pi epsilon 0 k q0. What is q0? Q0 it is called as test charge. What it is called as test charge, right? So q0 it is called as test charge. So divided by what, r square. Now, if you consider the electric field and R relation, the distance relation and electric field relation, the force relation and electric field relation, we can say E bar it is inversely proportional to, or E is inversely proportional to R square, and F is inversely proportional to R square. That means both follows inverse square law. Both follows what? Inverse square law. So both follows inverse square law. Inverse square law. Okay, so what is inverse square law? Inverse square law means something it is inversely proportional to r square. So what is the graph of this inverse square law? The graph of the inverse square law is, on the y-axis we will be taking E or F, while on the x-axis we will be having, on the x-axis we will be having distance r. So on the y-axis we are having electric field or force, on the x-axis we are having r. So electric field is inversely proportional to r. So this is the graph of electric field which is inversely proportional to r square, sorry, it is inversely proportional to r square. What is force? It is inversely proportional to r square, right? So if it is inversely proportional to r square, that means for the smaller value of r, electric field and force are what? Very high value, right? And for a very large value of r, electric field and forces are very less. So if suppose the distance between the charges are very large, then the electric field and forces are less, and whenever the distance between the charges are very less, the electric field and force are what? More. Okay. So this is all about electric field intensity due to a point charge. Actually, this portion it is removed from the syllabus, but it can be there. It can be there in the entrance part. Okay, but it is not going to include in the paper because this is the deleted portion from the academic year 2020 to 2021. Okay, so the next one there is also a deleted portion. So the next one we are going to learn is the uniform and non-uniform electric field. So when we can say that the electric field is uniform and when we can say the electric field is non-uniform. So if suppose the electric field it is what constant, the electric field it is what constant, is not changing. So the electric field it is like this. So the parallel lines which are equal in length, equidistant from each other, okay, and are in the same straight line, this is called as uniform electric field. This is called as what? Uniform electric field. While what is called as non-uniform electric field, non-uniform electric field means the electric field like this, it can be in random directions like this. So whatever may be the magnitude, whatever may be the direction, these are what electric field. So this is called as non-uniform electric field. So if suppose this is what a plus Q charge, this is the electric field which it is emitting. So we can say that when we consider the distance very nearer to the charge, the electric field values are what? Electric field values are strong. And as we go away from the charge, the electric field values are getting decreased. So this is again non-uniform electric field. So these two are non-uniform electric field. Non-uniform. That means at different positions, if suppose the electric field are changing. So at this position A, electric field is something else. At position B, electric field is something else. Here at position A, electric field is something else. At position B, electric field is something else. Then this is called as non-uniform electric field. This is called as uniform electric field because you consider any point, you consider point A or you consider point B, the electric field it is what? Constant. So this is called as uniform electric field. Okay. So what is the definition? A uniform electric field is a field whose magnitude as well as direction, is same at all points. So an electric field whose magnitude as well as direction is same at all the points, this is called as uniform electric field, while a field whose magnitude and direction is not same at all points. So at different points the electric field it is changing with respect to direction or with respect to magnitude. So that is called as non-uniform magnetic field. So this is the definition of uniform magnetic field. This is the definition of non-uniform magnetic field. Okay, non-uniform. Sorry, not magnetic field, electric field. Non-uniform electric field. Okay, so what is the diagram from your book? So these two are the diagrams from the book. This is what a parallel plate. This is what a parallel plate. So we can say the electric field between the parallel plates are always constant. This is what always is parallel to each other, and also they are equidistant from each other. Okay. So this is called as uniform electric field. While this is what a plus Q charge, I gave you example of this. If you consider point A, electric field is very strong. If you consider point B, electric field is weak. Why? Because they are present at different distance. And we have understood that electric field is inversely proportional to the square of the distance. So as the distance changes, electric field is going to change. Okay. So this is all about the uniform and non-uniform electric field. So what is the next topic that we are going to learn is the practical way of calculating the electric field. So the practical formula for calculating the electric field. Now what is this formula? Electric field formula we have force divided by charge. We have force divided by charge. Now force divided by charge is not the practical formula of calculating the electric field. So in the next concept we will be understanding the practical way of calculating electric field. Okay. Thank you so much all of you for paying attention. Keep learning.